I'm going to talk to you about learning theories for teaching mathematics. My name is Jessica Lovett. So first up, I'm going to talk about discovery learning and constructivism theory. I paired these two together because they are related and quite similar in my opinion. So first up, what is the theory? So discovery learning is the idea that students should problem solve on their own and be given the opportunity to discover their own reasoning. Discovery learning is essentially constructivism applied to problem solving. Students will benefit from constructing their own knowledge rather than acquiring it from the teacher only. So when and why would this work? These theories would work if you were trying to teach students, say, how to add fractions using linking cubes, for example. So students are given the opportunity to work with the linking cubes and figure out why it is critical to have a common denominator. They can construct and discover their own knowledge and develop for themselves the proof behind a theory without the teacher saying, this is true and that's that. When would this not work? Discovery learning and constructivism would not work when students lack background knowledge of the concept. You can't build a house without a foundation, and similarly, you can't construct your own reliable knowledge if you have no foundation of the concept at hand. So next up we have humanism paradigm. So what is this theory? This paradigm states that learning is centered around the student and the teacher's role is simply to facilitate. So when and why would this work? I think this would work in all subjects, including math, because we should be trying our best to make subject matter about our students' lives. Some students will just learn material because you say so, others are going to need a reason, and that isn't an invalid request. In math, instead of teaching high school students how to simply solve for x in a linear equation, make a story surrounding the problem so they attach an item to x. Humanize the problem, and they may still hate math, but maybe they will care a bit more about solving for x. When would this not work? Well, humanism would not work if you have a very diverse class with little similar interests. You cannot write 25 individual math problems to make a question relevant to everyone's life, so it may not work in all cases. I do feel, however, that to avoid the question why from students, we need to gear math down to a level so that students can see the relevance without having to ask. The next theory is elaboration theory. So what is this theory? This theory essentially states that subject matter should be taught in sequence, starting with the most basic material to the most complex, in order to maximize learning. The idea is to start with the most basic and then continually elaborate from there. When and why would this work? Well, this theory is basically common sense, and I've never met a teacher who would think it was a good idea to teach the cross product before learning about vectors, for instance. So again, I think this theory, and I use this term loosely, should be used for all subjects, but most specifically for math. Almost everything in math builds off a previous concept. Before one can teach how to make a circle graph, students need to have an understanding of percent in portions of a whole, so they can convert the percent to degrees. They also have to understand how many degrees are in a circle. All this prior knowledge must be obtained just to build a seemingly simple circle graph. When would this not work? Well, the only time this theory may not work in the math classroom is in some unique cases where certain students may benefit from a different sequence of material. For example, do you teach multiplication before division, or vice versa, or at the same time? When I worked at a tutoring center, I remember students in grade 2 coming in baffled because they started division and had no idea what was going on. I wondered what would have happened if division was taught simultaneously with multiplication instead of after. Division is not harder than multiplication, it is merely the opposite. Students can't seem to make that connection because after doing weeks of multiplication, division comes out of nowhere. In most cases, it would be quite obvious to us what we should teach first, but there are some instances where it is hard to judge what the best order is to ensure student success. Another theory helpful for teaching mathematics is problem-based learning theory. So what is this theory? So problem-based learning is a method which allows students to investigate real-world problems and try to solve them to the best of their current ability using their prior knowledge and available resources. When and why would this work? This type of learning would work wonders in a math class because there are so many real-world problems that require a mathematical solution, yet still do not have a definitive answer. Many see math as being black and white. Either it's wrong or it's right. That isn't always the case. Many solutions are approximations, albeit extremely accurate estimations based on complex formulae, but nevertheless not a perfectly accurate solution. Teaching students that having a small margin of error is okay helps them to see that maybe there is more than one way to solve something. By giving a problem to students, like a Fermi problem, that doesn't have an exact answer, gives them the freedom to be creative and not fear failure. They can't technically get the wrong answer because it doesn't exist. Sometimes in life, it is how you justify your method that carries more weight than your final answer. And when would this not work? Well, problem-based learning may not work for all concepts. Students need to be aware that there are many math problems in which there is only one correct answer. You can't say that 2 times 4 equals 6 and then find a convoluted way of justifying how you got that answer. Furthermore, in order for students to have the tools, like addition, multiplication, derivatives, etc., to solve complex real-world problems, you must teach them the essential concepts first. And trying to teach addition through problem-based learning may pose some problems. Last but not least, we have experiential learning. So what is this? So this theory states that our knowledge is created by transforming our experiences. When and why would it work? I think this theory works well in math for any concept that involves written calculation. Oftentimes in university, I remember my professors would explain a concept in words and tell us what was happening, but it wasn't until they put the formula down and let us work out a solution on our own that it all made sense. In math especially, some concepts can be very hard to explain, like derivatives, for example. Just explaining that the first derivative is the rate of change doesn't mean much. If you show a student a problem and give them a formula and numbers and ask them to solve it on their own, it tends to sink in better and make much more sense. So when would this not work? Well, experiential learning may not work in cases where concept is not necessarily explainable at the grade level being taught. Oftentimes, the formulas we use are works of great mathematicians that came before us, and although we can teach students to learn how to use these formulas through experience, it may be hard to teach how the formulas came about through experience.